Hey, Karim is back on this one, and I already told you all what I'm going to be up to on this video, and from the start you already know what is up. So we are going to be achieving a certificate to our portfolio, and that will be certified AppSec practitioner. I already have the other one, that is CNSP, that is certified network secured practitioner. I already achieved that one, like I think last month or last I think last month. I got that one last month. So now today on this video we are going to be getting the next one, that is the certified AppSec practitioner. Yeah. So but before then we have the leverage of doing a mock exam before we go for the actual exam. So on this video we are going to be doing the mock exam. Since the mock exam will not be monitored, I can show you the process of me writing the mock exam, show you the score I get on the mock exam. Then from the mock exam, then I will now go for the video for the exam, for the main exam. But for the main exam, since I cannot record myself doing the main exam, maybe I'll just maybe on one spot or maybe on this spot, as I'm recording myself not from the system. I will be writing the exam, but I cannot show you the screen. I can't show you nothing, just me writing the exam without anything being shown. But on the mock exam, I'll show you like how, like what I'm writing, the options that I'm getting, and what I'm picking, and the score I get after I go. They'll show me the score after the exam. So without no further chit chat, let's get right into it. So we are going to be going for this certified AppSec practitioner. So let's take the mock exam. This is the mock exam though. I think the mock exam will not be, see, it's not going to be invigilated. Just test someone. So in the context of the following JSON web token, which of the following statements is true? That is, we have this, and we have this. These are separated by dot, and this one, this is the signature, this is the payload, and this is the header. So we have the header here, we have the payload here, and we have the signature here. So in this question, it said that which of the following statement is true? That means this string represents a JSON web token signature, which is not the answer. We have this represents a JSON web token signature here, which this represents the web the token signature. This, I think our answer is this. Yeah, based on the screenshot below, which of the following statement is true? All right, the application is using an outdated server Microsoft. Yeah, this is an old version. So this is an old version Microsoft server. The application is disclosing the server version. This is server version is disclosing it. The application is disclosing the server, the version of the framework used. This version of the framework. Yeah, and here is it. So all of the above. Which of the following directive in a content security policy HTTP response header can be used to prevent a clickjacking attack? Frame ancestor. Which of the following SSL TLS protocol are considered to be insecure? SSL v2 and SSL v3, TLS v1, and TLS v1.1. So these two are old version of SSL and TLS. So both A and B. So SSL 2, SSL 3, TLS v1, TLS 1.2, and TLS version 1.3. Now we have an early models of this, and that is for this and this, which are the early models. So this is not part of the answer. After purchasing an item on an e-commerce website, a user can view their order details by visiting the URL https://example.com/order_id 870. A secure researcher pointed out that by manipulating the order_id value in the URL, a user can view arbitrary order and sensitive information associated with that order ID. There are two fixes, bug fix. In order to fix the vulnerability, a developer called Bob devised a fix so that the URL does not disclose the numeric value of the order_id, but uses a SHA-1 hash of the order_id value in the URL, such as https://example.com/?_id equals to the hash value of SHA-1. Then note that the SHA-1 value of this number is this hash. John fix. Another developer called John devised a different fix so that the URL does not disclose the numeric value of the order_id and uses a base 64 encoded value of the order_id in the URL, such as https://example.com/order_id equals to the encoded value. Note that the base 64 encoded value of this number is this encoded value. Which of the following is correct? Both solutions are adequate to fix the problem. Both solutions are inadequate and vulnerability is still not fixed. Only John's solution fixed the problem. Only Bob's solution fixed the problem. Now the problem here is that after purchasing an item, a user can view their order details by visiting the URL. So by visiting this URL, you can see your order. The security researcher points out that by manipulating the order_id value in the URL, a user can view arbitrary orders and sensitive information associated with that order_id. So what we are trying to prevent here is the order ID, so that users will not be able to view or change or manipulate the order. So for us to do this, we need to at least make sure that the person that is doing it, we need to authenticate the person. So since there's no authentication going on here, that means the both options are insufficient for this, or like none of them is really helping the matters here, but they are just trying to just obfuscate the numeric value, but they have not yet solved the underlying problem. So both solutions are inadequate and the vulnerability is not fixed. So let's see what we got. Yeah, and that is going to be my start for the mock exam. So right about now I'll go and write the main thing. So you guys will wish me luck, and after that I'll show you guys my start after I'm done. So stay along, and until then, peace. What? That is crazy, man. That is crazy. You was same score I got in my certified network security practitioner, and this is my certificate.